So Charles' law, this law describes the relationship between temperature and volume. Okay. Temperature and volume at constant pressure. Yesterday we talked about Boyle's law. Boyle's law was pressure and volume at constant temperature. Okay. So we're going to be comparing all these different relationships. So Charles' law states that temperature is directly proportional to volume. Directly proportional. Yesterday they were inversely proportional. Today they're directly proportional. So Charles' law is V1 over T1 equals V2 over T2. Now something very important about Charles' law, temperature must be in Kelvin. Okay. Temperature must be in Kelvin. So remember, to get to and from Celsius, you take a degrees Celsius and you add 273 to get something in Kelvin. Or if you start with Kelvin, you subtract 273 to get something in degrees Celsius, right? So for example, problem number 1, if I have 45 liters of helium in a balloon at 25 degrees Celsius, now notice that word at, okay? I have 45 liters at 25 degrees Celsius. Those two numbers go together. So those are either both my starting volume and temperature or my final volume and temperature, but those two must go together, okay? And I increase the temperature of the balloon to 55 degrees Celsius. What will be the new volume? Now, first of all, we're going to have to go through and change each of these degrees Celsius to what? Kelvin. So let's add 273, add 273. So I get 298 here and 328 here. Both of these are now in Kelvin. The unit changes. So we go through and we plug in all the numbers we know. 45 liters. Liters is volume, so that was my starting volume. 298 Kelvin now was my starting temperature. And 328 Kelvin was my final temperature. Okay. Oops, not going. Plug everything in. And then in this formula, you get to do the kind of math most of you seem to enjoy. You get to cross multiply. 45 times 328 divided by 298. And I get 50. Now I need to make sure I'm paying attention to sig figs here. Okay. So in the questions, I have 2 sig figs with 45, 2 sig figs with 25, 2 sig figs with 55. So my answer should have 2 sig figs. How do I make this have 2 sig figs? 50.0. Not 50.0 is 3, just 50 point. Having a decimal place there means it is exactly 50. Right?
Wait, are you saying that we start?
For example, problem number 2, I have 130 liters of gas and a piston at a temperature of 250 degrees Celsius. If I cool the gas until the volume decreases to 85 liters, what will the temperature be in degrees Celsius? So 130 liters at 250 degrees Celsius. Those two numbers are going to go together. And it says that I'm starting with that because I cool the gas. So this is my starting volume. I plug that in. This is my final volume. I plug that in. In order to plug in my temperature, I need to change my unit. It must be in Kelvin. So plus 273. Okay. I get 523. So I get 523. My unit is Kelvin. I plug that in. Okay. Remember that goes with my 130? Ooh. That what I was going for? Ooh, weird. Well, you get it. 523. When I calculate this, I get 340 Kelvin. But my answer asked for a specific unit. If you just put 340 Kelvin, that wouldn't work. Okay, it asked for your answer to be in degrees Celsius. So make sure your answer is in degrees Celsius. So to go from Kelvin to degrees Celsius, I subtract 273. Check my sig figs. 85 is 2 sig figs. 130 is 2 sig figs. 250 is 2 sig figs. So my answer should have 2 sig figs. Okay. Remember, the least amount of work that you can show me is this. You must plug everything into the equation and have the answer. Whether or not you show the work to work out the equation, I understand you can do that in your calculator. But you must show you plugging the numbers into the equation. That's so I can know where the mistake was made. If I just have an answer, that doesn't help me to know where the mistake was made. Now, we said that this is directly proportional. Because it's directly proportional, if T is increased, V will increase. Same thing. If T is decreased, V will decrease. Okay. I've just got one more thing for you that I'll go over. For number 2, I won't do it with you, but I'll point something out. It starts with, the temperature inside my refrigerator is about 4 degrees Celsius. That's just a fact. It's not saying anything has happened yet. It just says, the temperature inside my refrigerator is 4 degrees Celsius. Now, it actually goes into what happens. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will be the volume of the balloon when it is fully cooled in my fridge? This word initially, if you don't know what this word means, this is your vocab word of the day. Initially means what you start with. So when you ever see the word initially, that means that the following, this must be V1 and that must be T1.